Okay, let's discuss a question from theory of machine. It's basically from the vibrations, the value of the viscous damping coefficient for which the system is critically damped. Now, when you have a single spring and a damper, okay, so in that case, for underdamped case, we derive this equation. The damping coefficient and the damping ratio are related in this. Now the damping coefficient for critically damped, that means damping ratio is 1, is given by this K by M. Now this case we need to convert in this case, and that can happen only when, so this is a case where the springs are in parallel. Now why I say parallel? Well, if you deflect the spring, if you deflect the mass to, let's say, top or left, if let's say if you deflect the mass to bottom, the force that is coming from the top spring will be upwards, and also because when you deflect the mass towards bottom, the top spring will be stretched, so it will try to come back to its initial position, so it will apply a force like this, whereas the bottom spring will be compressed and it will want to go back to its initial state, so it will also push. So the effective force will be again acting in the same direction. Both the springs will behave in terms of the force in the same way. They are in parallel. This is a state in parallel. So the effective, so the way you convert this system into this is the K effective, it's in parallel, so K1 plus K2, so it is 35 plus 35, it's 70 kilonewton per meter. So that is your effective stiffness. So now I can just use this. So damping coefficient is as C2, mass is given as mass is 36 kg into K effective is 70, so 70 into 10 power 3 kilonewton, and mass is 36. So this is something which I need to calculate, and this comes out to be 3174.90 Newton second per meter, because that is force per velocity, so it will be Newton per meter per second, so it's Newton second. So roughly it's 3175 roughly into Newton second per meter. So that is, and what is asked is kilo in kilonewton. The answer, if you say it's in kilonewton, so it is 3.175 kilonewton second per meter. So the answer for this will be 3.175 kilonewton per meter. Thank you.